It's probably no secret given the state of the channel recently, but I've become quite enamored with this little bitty chip here. This is the Motorola MC14500. It's a 1-bit microprocessor. And I've become so fascinated with this chip that I've decided to try and rebuild it using vacuum tubes, which is a hilariously fun project and one that we're currently actively working on and making progress on. But there's a lot of really interesting quirks to this chip. Because the chip was originally intended as a replacement for programmed logic controllers and relay systems, a lot of features that are generally packaged into a microprocessor have been removed, essentially offloaded out of the microprocessor. And there was a couple of reasons for this. One, this chip suited really well for the type of PLCs that it was intending to replace, but also it gave the designer a lot of freedom in how they wanted to design the rest of the system, which is one of the reasons why I'm really fascinated with the chip. For example, the program counter is not built into the chip, which means as somebody who's designing the system, you can build the program counter to be as big or as small as you want. But theory is all really nice. Looking at the data sheets and all of this, reading through it is really great, but I want to learn more about the chip, and the best way to do that is to essentially build the chip up on a system. Build something with a program counter, something with some memory that we can access. Maybe we can store a program in there. Maybe we can get it to run something. And I think this is really important for also the tube project, because it'll give us some insight as to what direction we need to go in after we get the primary tube replica functioning. So that's what I want to do today. I want to start another project that's going to run simultaneously with the tube project, where we build up this little MC14500 on a breadboard and try to learn and experience it and see what kind of quirks and shortcomings it has and see what kind of strengths that we can get out of it as well. So let's hop over to the bench. We'll take a look at the overall plan, and then maybe we'll build our first circuit on there today. Well, first things first, we need to come up with an overall plan of what it is that we want to build. And what I have here is my notebook. I keep all of my personal reference material that I really like. I have some fantastic printouts from the IBM 604 manual as well as the 650 manual. But I also have an entire section with useful printouts for the MC14500B that came from a really great manual for it that goes into a lot of detail about it. And, you know, obviously they have the block diagram as well as with what all the instruction codes do. But what I'm really interested in comes in chapter 4 here, where they talk about hardware systems. In this section, they have some wonderful reading material about this, but I'm a big fan of, you know, diagrams like this because they're a lot easier for me to understand. And actually, this is kind of exactly what I want to build. And you can see that they have the MC14500 right here in the middle. And then they've got two 4-bit counters up here at the top. And those 4-bit counters feed into a memory module. And they create an 8-bit address for the memory module, and that memory module gives an 8-bit number out. And that 8-bit number, 4 of those bits are used for the MC14500, and the remaining 4 are used to control these chips down here. And these down here are going to be the input, the output, and then we have a scratch register. And so the scratch register means that we can write to it, and then we can also read back from whatever we wrote. And so this is what I want to build. This is, I think, an awesome design. It's, you know, what they say, a minimal system, and it's a great way to learn about the MC14500 and what kind of supporting circuitry is needed to really pull the most out of this chip. But there's a couple problems with this, and that's because it was designed around all of these very specific Motorola chips, and I don't have any of these. The only Motorola chip I have is this one. So I really want to build this with, you know, 7400 series logic chips here and here, and then just a generic memory module that I can find here. And so that means that there's going to need to be some changes, particularly in this area down here. I mean, 4-bit counters feeding into, as an address into a memory thing is pretty universal, whether it's a Motorola chip or not. But these Motorola chips down here are pretty unique, and they have some really interesting features that are going to cause us some issues when trying to replicate with 7400 series chips, I think. Because the more I read about these, the more complicated they're seeming. But I think this is an excellent starting point. And so essentially what I want to do is just start at the top and work my way down, build each step as we go. Now there is one thing that isn't shown on here, and that's the clock. And the clock is this X1 here, which comes into the clock pin here and here, but they're not showing what's driving the clock. And so actually that's what I want to build today. I want to just build the clock. And so for the clock, I want to have two specific functions. One, I want to be able to flip a switch and just let the clock run. And I want that clock speed to be adjustable within kind of a reasonable range. The whole thing's going to be really slow because I want to see the lights flash. And then I want to be able to flip a switch and have the clock set to advancing by just pushing a button. So we're going to need a debouncing circuit as well as just a regular clock circuit. And so we can do this pretty easily with the 555 timer. So let's pull our breadboard out and see if we can build those up. All right, before we get started, let's talk about breadboards. One of my absolute favorite channels on YouTube right now is James Sharman's channel. And he's building an 8-bit pipeline CPU, and he's starting by building it on breadboards and then slowly moving it onto PCBs. Now, I say slowly moving onto, I'm only on like episode 40 of 80 plus. So I don't really know what the current state of it is, but where I'm at, it's kind of partially on PCBs and partially on breadboards. But he's fantastic and just amazing to watch, but that's a lot of breadboards. I don't have that many breadboards, but I do have this awesome 1 unit breadboard thing. And I think it would be really cool to build the entire thing on this breadboard, which essentially just means that I'm using just 4 breadboards with power rails shared between them. So it's going to be pretty tight, but I think I can do it. James is building everything from scratch, which is absolutely amazing. Please go check out his channel. But the Motorola MC14500 has a ton of functionality built into it already. So really we just need to put the supporting circuitry for that chip onto this breadboard. And I think we have enough space to do it. And I'm kind of imagining it, you know, like clock and program counter, maybe memory, then the ICU itself, and then input output or something like that as we move down. And I think we have enough space to do that. Now, one of the other things that James does amazingly well is bend his own jumper wires. He'll measure them out, cut them, and bend them. And he's even gone as far as building custom 3D printed jigs to make sure that the jumper wires have the exact right shape. It's incredibly satisfying to watch, but I am way too lazy for that. So what I'm gonna do is I'm just gonna use these little jumper wire kits that I got off of Amazon. There's a bunch of these, and they come with a pretty standard assortment of sizes. There is a couple problems with these, from the smallest size all the way up to about this mid-range size right here in the middle. They go up by essentially 1 space. So that's great for smaller connections, but as soon as we start getting longer connections, they start skipping a bunch. And so there's probably going to be some situations where an orange wire is too long, but the gray wire over here is too short. And so we have to come up with some interesting ways to route them. But like I said, I'm incredibly lazy, so I am just going to use those and hopefully get them bent around to how I want them to be. All right, let's get started. And I want to start with the single step portion of the clock. So I'm just going to put in a little button here and job done. Awesome. Not quite. First of all, this isn't hooked up to anything. And second of all, these buttons are incredibly bouncy. It bounces when you push the button and it doesn't make a complete contact. It'll maybe kind of bounce a little bit. And that can be interpreted as multiple clock pulses. So we really desperately need to debounce this switch. And in order to debounce it, I'm just going to use a little 555 timer. All right, there's a ton of 555 timer debounce circuits out there, and the 555 timer itself is probably the most ubiquitous IC in history. It's used for everything. People have built some really wild things out of the 555. So I just Googled a 555 debounce circuit, found one that I liked, and adjusted the capacitor and resistor values until I was happy. So let's just go ahead and hook this up. And we'll do the basic connections first. Pin 8 is power, so it goes to VCC. Pin 4 is reset, so we're going to pull it high. And pin 1 is ground. And you can see the first problem with using these jumpers out of the pack here, and that is that our VCC and our ground jumper here are equal distances, so they're the same color. So we have orange for both of those. And then over here where we're pulling pin 4 high, we're using actually a gray jumper because it's a little shorter. So the colors end up just not meaning anything at all, which can be a little confusing. But again, like I said, I am colossally lazy, so I'm just gonna roll with this. All right, pin 2 is our trigger, and that goes through the button to ground, as well as has a 10,000 ohm resistor that is pulling it up to VCC. And the irony of jumper colors strikes yet again. We're using a bright red jumper to go from ground to this button here. Again, the colors don't make any sense at all. Pin 3 is our output, so we're going to use a little jumper to move it to the front side of the chip, and then we're going to use a little switch to switch it in between the single step or the actual clock itself. So here's my little switch. All right, and so when the switch is in the left position, that connects the center pin with the left pin, and the center pin will just be our ultimate clock output. And then if I put the switch in the right position, that connects the right pin with the center pin, and that can be our actual clock. Now moving over to the backside here, pin 5 goes to ground through a capacitor, and I'm using a 47 nanofarad capacitor for that. Now pins 6 and 7 are tied together, so we'll use a little jumper to tie those together. And then one side of that junction between the two goes to ground through a large capacitor, and then the other side goes to VCC through a 10,000 ohm resistor. So the capacitor that I'm using to go to ground is a 47 microfarad, and then I'm going to use a 10,000 ohm resistor to go to VCC from there. All right, that's everything, except that we can't really see our output. So I'm just going to run from the center pin. I'm just going to run through a 10,000 ohm resistor because that's actually a huge resistor for an LED. But I'm using this blue LED here, and it is insanely bright. So the bigger resistor will keep it from being a little blinding. All right, let's hook up some power to this and see if our debouncing circuit works here. So just hook up a little positive and negative here. There we go. That should work. I don't know. Let's push the button and find out. Yeah, there we go. Okay, so you can see it's kind of a long press, which is good. That means I push the button and it starts the timer, and then the timer stays on longer than a standard button press. And so that ensures that we get a really clean signal without any errors being introduced to there. Awesome, that works out great. So let's just let's go ahead and disconnect ground here. So we're not running power through our power rails anymore. We'll move you out of the way a little bit too. There we go. Okay, so now let's build the regular clock. And again, there's a ton of different circuits out there to build a clock. I'm going to use the 555 timer, and if you just Google 555 timer clock schematic, you'll find a ton. I just looked around and found one that I was quite happy with, and then I had to just tweak the capacitor and resistor values just based upon what I had in my parts bin. But I'm going to use the 555 timer, so we'll just go ahead and toss that guy in right there. And then basic setup again, pins 4 and 8 to positive and pins 1 to ground. Interestingly, pin 2 and pin 6 are connected together, so you kind of have to bend up a little jumper to go around the end of the chip there. So there we go, that's pin 2 and pin 6 connected together. And then those two pins go in two different directions. One is to the potentiometer that's going to control our speed, so I'm just going to put a jumper to move that out a little bit, and we'll deal with that here a little later. And then it also goes to ground through a capacitor. So I've got a little 4.7 microfarad capacitor here that I'm going to use. So we'll just go ahead and pop that in over here. There we go. All right. Pin 3 is our output. So I'll just use a little jumper here to move pin 3 over to our switch here in the center. Pin 5 goes to ground through a capacitor, and I'm using a 22 nanofarad here. Now, don't take my values as gospel. I'm pretty much just using whatever I had quick and easy access to. Now, pin 7 needs to go to VCC through a 1000 ohm resistor, but I'm kind of out of room, so I'm gonna lift up this jumper here and scoot it over a skosh. There we go. And then we can hook up our 1000 ohm resistor to VCC and pin 7 there. All right. Pin 7 also goes through a 1000 ohm resistor to the center pin of our potentiometer. So we'll just run that little resistor right there. And then we'll use two little jumpers to jumper on down to here so I have a place to hook up my potentiometer. And I have these huge potentiometers which look epic, but take up a lot of space. But that's going to be super easy to operate. Now, unfortunately, this potentiometer is supposed to be pretty big, but I've only got a 100,000 ohm potentiometer, so we'll just have to work with it and see how it goes. All right, I think everything is hooked up correctly, so let's go ahead and put power back into the circuit here. All right, now let's see if our single step still works. Yeah, okay. Now let's go ahead and just turn you all the way down that way. That over? Yeah, look at that, there it goes. Let's see if we can adjust the speed. Yeah, that's pretty slow. Let's see how fast we can get it going. Fast enough that it looks like it's on all the time. Now that's not incredibly fast. We're not gonna get anywhere near the 1 megahertz that the MC14500 says it can run up to. But the whole point of this is to actually keep this running pretty slow, maybe about a speed like that, so we can actually see where the data's going. But this is really cool. We have a great debounced single step, and we also have a clock that we can now pipe into different spots on the board. One last jumper that I want to add is that this clock is going to be needed in a couple of different spots, I think, and so I want to just go ahead and move it out to this far rail out here. So that way, if I need it somewhere down here on one of the different breadboards, I can pull it off of that rail instead of trying to snake something all the way up here. So I'm just going to run a little jumper for that. All right, so now our clock circuit is complete. It's ready to clock something else. So next I want to build the program counter, and I think I'm going to build it on this half of the breadboard. But I think we'll save that for the next episode. In the meantime, this is just really, really cool. I'm super happy with how this turned out. It's pretty compact, and it looks really neat. So thank you guys so much for watching, and we'll see y'all in the next episode.